Hello students, in the last class we had discussed milling machine. So milling machine is one of the important machine tool which is used to produce various machining surfaces. So we had discussed basically two types of milling machines, that is horizontal spindle milling machine and vertical spindle milling machine, its parts and its construction and working. Now once we know about a particular type of machine tool, so any machine tool is used to perform certain operations, or certain operations can performed on a workpiece using that particular type of machine tool. Now here we are talking about milling machine. So in milling machine, basically we have discussed two types of milling machine, that is horizontal spindle and vertical spindle. So just to recall that horizontal spindle is one where the spindle axis will be in the horizontal direction, whereas vertical spindle milling machine is one where the spindle axis will be in vertical direction. So as it was discussed in the previous class, so milling machine is one of the machine tool where we can perform a number of operations. Basically it is used to cut teeth, that is on a gear. So other than that, it is also used to perform other operations. Now here today in this session we will be discussing a few of the operations that can be performed on a milling machine. Now here before going to the operations, so here some of the operations can be performed on vertical milling machine and some of the operations can be performed on horizontal milling machine. That is one thing that has to be taken into account. Second important thing is that here cutter is not same. So different type of cutters are used for performing different operations. So one thing is it can be performed on a horizontal milling machine or it can be performed on a vertical milling machine. Second thing is that, so depend upon what is the operation we are performing. So what is the operation we are performing, we use that particular type of tool. So these are the two variations we have to observe before going with the discussion of what are different operations that can be performed on a milling machine. We'll start with the first one. So first operation was plain milling or slab milling. So plain milling, so producing a plain flat surface. So producing a plain or flat surface, that's why the name given is plain milling. Slab is once again producing a flat slab, that is horizontal surface on a slab, horizontal surface on a slab. So hence it is also called as slab milling. So this is the operation, the first operation that can be performed on a milling machine. So this operation, you can observe the sketch. So the spindle axis is horizontal. The spindle axis is horizontal, means it is performed on a horizontal milling machine. Now this is the table. So on the table the workpiece is fixed. This is the workpiece and this is the tool. The tool is called as plain milling cutter. So in case of horizontal milling machine, we will be having a harbor. On the harbor at the center the tool is fixed. On the harbor, on the center of the harbor, tool is fixed and one end of the harbor is connected to a spindle. One end of the harbor is connected to a spindle. So the motion is got from the spindle to the harbor rotates and in turn the tool also rotates. So this is the plain milling cutter. So plain milling cutter. So what is plain milling? So plain milling is an operation that is performed to produce horizontal or flat surfaces on a given job. Producing horizontal or flat surface on a given job. Now how this particular operation is performed? It is performed on a horizontal milling machine. The cutter what we use is called as plain milling cutter. So here the cutter is fixed on the harbor and the workpiece is fixed on the table. So then the machine is switched on, milling machine is switched on. So as the machine is switched on, so the spindle starts rotating. Motion is transferred from the spindle to the harbor. So harbor also starts rotating. So harbor also starts rotating. So here it is the direction in which the harbor starts rotating. So as the harbor rotates, the cutter also rotates. So the surface is like this. So the cutter rotates like this. As the cutter rotates, so the table is moved up and the surface of the job is brought in contact with the surface of the cutter. So as it comes in contact, the material is removed. So this is the width of the surface that has to be machined. So entire surface will be machined in single stretch. Entire surface will be machined in single stretch. So once the required amount of material is removed from the surface of the given job, the machine is switched on. Once again table is lowered and workpiece is removed. Workpiece is removed. Now here you can see this cutter. So cutter, these are the teeth on the cutter. So these are the teeth on the cutter. The teeth can be either straight or it can be helical. So if it is a straight teeth, so the cutter will be like this. So these are the teeth if it is a straight teeth. Now here it is helical. So helical teeth is one where the teeth will be at an angle to the horizontal surface. At an angle. So you can see this is the certain angle. So the cutter can have either straight teeth or it can have this helical teeth. So depending upon the finish that is required, depending whether you require a surface that is rough finish or whether you require a very good surface finish, so we can use that particular cutter with either the straight teeth or helical teeth. So this is the first operation that can be performed on a milling machine. It is called as plain milling or slab milling. Next operation is end milling. So end milling. So here you can observe the sketch. So two sketches I have written. So in both the sketches the cutter is in vertical direction. Cutter is in vertical direction. Means it is fixed to the spindle which is in vertical direction. So that concludes that it is the operation that is performed on a vertical spindle milling machine. So that concludes that it is these are the operation. This is the operation that is performed on a vertical spindle milling machine. So two different sketches I have written. So here this is the cutter. So cutter is called as end milling cutter, and this is the workpiece. So here the cutter here end mill cutter will have the edges on the inner surface or also on the outer surface and the bottom surface. So this is the bottom surface, it will be having the cutting edges, and here the bottom surface also will be having cutting edges, and the surface around it, it will be circular in cross section. So on the that is vertical surface also it will be having cutting edges. So here only on the bottom surface, not the edges. So here, so bottom also will be having the cutting edges, you can observe this, and whereas this the vertical also will be having the cutting edges. So that is one difference what we can compare with the plain milling that is operation. So end milling, it is called as end milling because the ends of the workpiece are cut. So end milling is the operation that is performed on a vertical milling machine in order to produce the slots or it is machining end surfaces. So machining end surfaces of the job. Now if this is the job, so plain milling horizontal surface is machined, whereas this vertical edges, so vertical surfaces machining, we can go for a plain end milling machine. So here how the operation is performed. So once again in all the cases one thing is common, table on the table workpiece is fixed, the tool is fixed. If it is vertical spindle, it is fixed to the vertical spindle, selecting that particular type of tool. If it is horizontal spindle, it is fixed on a harbor. So this is common in all type of that is milling operations. So a tool is fixed, so you can observe the direction. This is the direction. This is the direction in which the cutter will be rotated. So on the table the workpiece is fixed. On the table the workpiece is fixed, and then the machine is switched on. So once the machine is switched on, so the spindle, so this will be connected to the spindle, vertical spindle. Spindle starts rotating. So as the spindle starts rotating, the cutter also rotates. So the table is moved, and the surface of the cutter is brought in contact with the surface of the that is workpiece. So as it comes in contact with the surface, so it is brought here. So the material is removed on the end surfaces, So that is what here, or it can be this end also. So this end, so four ends are there, this. So as it brought in contact, so material is removed. So the surface will be flattened. End surface will be flattened. Here flat surface, here end surface. That is one particular operation that is performed on that is end milling. Here you can observe one more thing that is in the sketch. It is nothing but you can observe the same. So you have to remove the material in this slot. You have to want to create a slot. So then the cutter will be placed, the cutter is here, so it will move in this direction. It moves from edge to edge. So as it moves, it removes the material. So this is the end. So this is the direction of movement. So this is the direction of rotation of the milling cutter. So it moves like this, then the slot is gone. So you can observe this. So getting the slot like this on a given workpiece, so that is once again an end milling operation. So that is once again an end milling operation. So here this is the teeth. So teeth of the cutter will be, that is vertical. Teeth of the cutter will be vertical. So as it here it has got edges. So bottom surface also material is removed. The inner, that is edges also material is removed simultaneously. So as it moves like this, so edges and bottom surface material will be removed simultaneously. So the operations, the removal of material can be carried out faster when compared to a plain milling operation. So this is about the second operation that is performed on a milling machine, that is called as end milling. So it is an operation that is produced to, it is carried out which is to produce end surfaces. So end surfaces, so that is called as end milling operation. Then come to the one more operation, it is called slot milling. So slot, so we had discussed in the previous session, that is table will have slots, T slots. We call it as a T slots. So table will be having slots on which the workpiece is fixed. So cutting the slots on the table, cutting the slots T shape, it will be in the shape of alphabet T, hence it is called as a T slot. So that particular operation is called as slot milling operation, slot milling. So here once again, if you observe the sketch, so two sketches are being written. So it shows that the cutter is in vertical direction. Cutter is in vertical direction, means it is performed on a vertical milling machine. So here this is the figure which shows that cutting T slots. This is the figure that shows that cutting dotile, so that is slot. So it is nothing but in T slots, so edges will be vertical. So here edges will be at an inclination, So whatever may be the slot, whether it is a T slot or dotile slot, it comes under the slot milling operation. So slot milling operation, it is operation performed on a milling machine in order to cut slots on a given workpiece. Now here you can observe this sketch. So this is a slot that is already cut. Now here the T slot, so T slot will be matching with the cutter shape. So cutter will also have a T shape, so where we will be having edges, cutting edges here. So as it starts, so initially, so material will be removed and you can get the T slot. Similarly, if the slot is a dotile slot, the cutter shape will be in dotile shape, that is edges will be at an angle, inclination. So once again, as the material, the tool is fixed, coming to the operation, tool is fixed on the, that is spindle. So workpiece is fixed on a table, table is moved. As the surface comes in contact with the it is workpiece surface, the required slot is cut on a given job. So that is called as third operation, it is slot milling. Then coming to the next one is angular milling. So angular milling is an operation that is performed in order to get an angle cut. If you want to cut a angular surface, so you can, once again, two sketches are there. It may be like this also, where if you want to cut this surface, the vertical surface should be cut an angle. So then once again we go for angular milling, or cutting V-shaped notch. So V-shaped notch. So then we go for this angular milling. So angular milling is an operation that is performed on a milling machine in order to get angular surfaces or V notch. So example is V notch. So it is called as a notch. So V notch, so it will be in the shape of the alphabet V. So here if you observe the figure, so the cutter is in horizontal direction. So cutter is in horizontal direction, means it indicates that it is performed on a horizontal milling machine. It is performed on a horizontal milling machine. So cutter is fixed here on the harbor. The workpiece is fixed as usual on the table. So workpiece is moved. So this is the shape of the V notch. So the cutter will be of the same shape. So very important. So what should be the inclination of this notch, V notch? So the cutter edges should be of the same inclination. So then the workpiece is moved above, workpiece is moved above, it is brought in contact with the surface. So then gradually as the tool comes in contact with the workpiece, material is removed. So until we get the V notch. So once the V notch, the required amount of material is removed on the surface of the given job, so the machine is stopped. So this is one-sided, you can see that. So this is two-sided notch. So this is one side, you can see. So inclination is only on one side. So whereas other edge is vertical. So this is also comes under the angular milling. So or you may have a surface like this. So where if you want to cut an angle, so edges should be at an angle. Surfacing of the edges should be at an angle. So here it is vertical. So here it is an angle. So when you want to get that surface on a given job, so then the same operation, using this same operation, we can get that particular surface. So these are the four types we have discussed: plane milling or slab milling, end milling, slot milling, and angular milling. Whereas plane milling and angular milling is performed on a horizontal milling machine, end milling and slot milling is performed on a vertical milling machine.